Okay, let's check our 82 and our 84. And then on my calculator, I do 71 times 15. I canceled 12 into 180 and got 15. Then I'm going to do 71. So there was 180 divided by 12. That gave me 15. 71 times 15 is 1,065. So this is 1,065 degrees. Then 84. I'll put my degrees up there. The pi's cancel. 6 goes into 180 30 times. And 11 times 30 is 330. So 11 pi over 6 is 330 degrees. Okay, now I've just got one little bit of notes I would like you to take. So you can either go back to section 4 where if you had room, maybe right here in this spot, if you didn't use it when you were working out problem 64 for a previous assignment. If you don't have room to put it here, then maybe you can put it somewhere here. Or actually, you can put it right here on the unit circle if you want, because that's going to be a separate handout. I want to explain to you where radians come from. So I'd like you to draw a circle, as best you can draw a circle, okay? And put a dot where the center is and mark off a radius, okay? Now, if you remember anything I taught you from geometry, and I think I taught you all geometry, maybe, circumference is 2 pi r. And I just told you that radians all the way around a circle were, excuse me, 2 pi. So a radian is related to the circumference, and it's related to the radius. Okay, now I want you to imagine if your radius was a piece of yarn. Now in the past, when I was actually in class, I've had students do this with a piece of yarn. If you want to get a plate or something round and try it with a piece of yarn, you'll see. If I were to take my radius as a piece of yarn and I were to lay it on the circle, one radius would go from about right there to right there. Okay, then the second radius would go to about right there. Then if I were to still take my little piece of yarn and lay on the radius, the third radius would end up about right there. The fourth one would end up about right there. The fifth one would end up about right there. The sixth one would end up about right there. And you've got this little gap right here. It ends up being 0.28 of another radius. Okay, 0.28, almost a fourth of another radius. 6 whole radiuses and 0.28 of another radius. 6.28 is 2 pi if you were doing it exactly. So you can fit 2 pi radiuses around your circle. 1, 2, 3, 4, 5, 6, and there'd be a little gap there, which is 0.25. Okay, so mathematicians a long time ago decided to say that 1 radian would equal the angle that 1 radius marked off. So this angle right here, okay? Well, if you want to know what 1 radian is in degrees, you can just do 180 divided by pi, 180 divided by pi is 57.2957795. So we're just going to round. 57.3 degrees equals 1 radian. So obviously radians are a whole lot bigger than degrees. So 180 degrees is pi radians. So if we did that as a decimal, 180 degrees is 3.4, going on forever, radians. So 1 radian is a heck of a lot bigger than 1 degree. 1 degree is this tiny little sliver down here. There's 360 of those, but there's only 6.28 approximately radians in a circle. So 57.3 degrees approximately is 1 radian. Okay? 1 radian is the angle that 1 radius marks off. So if you took a plate and measured the radius with a piece of yarn and laid those pieces of yarn around, you would get 6 whole pieces of yarn and then a quarter more left over. So something important to know. Okay, that concludes your videos for today. Look on LMS to see what I want you to do for homework. Thanks.